Good afternoon, class. We're looking at Chapter 3, Derivatives, Section 3.1, Derivatives and Rates of Change. So, Chapter 3, we're going to cover derivatives and rates of change, the derivative as a function, basic differentiation formulas, the product and quotient rules, the chain rule, implicit differentiation, related rates, derivatives of the logs, differentials. I want to mention in this section and the next section, we use definitions, which means as of the third section, we start with basic differentiation formulas. You cannot use differentiation formulas for your homework for this module or for the first exam. And so reminding you again of what we have just gone over, finding limits, limit of f of x as x approaches a equals L. In the case of a sequence, limit of a sub n as n approaches infinity is L. We say a sub n converges to L. If it's infinity, negative infinity, or doesn't exist, we say it's diverges, and of course, we just plug in and observe. If you look at all these three cases, the limit of f of x as x approaches a exists and it's equal to L. So what's the difference? The first case, f of a is also L, makes it continuous. Second case, f of a is something else, b, makes it discontinuous at a. And in this case, f of a is undefined. The line y equals L represents a horizontal asymptote. If the limit of f of x as x approaches either infinity or negative infinity is L. And x equals a represents a vertical asymptote. If the limit of f of x as x approaches a, or a from the left or right is negative or positive infinity. One-sided limit simply means limit exists if both sides have the same limit, and continuity if the limit and the functional value are the same. In other words, limit of f of x as x approaches a equals f of a. So this is what we have covered. And now, section 3.1, derivatives and rates of change. Given the function y equals f of x and point P with the coordinates a and comma f of a, the slope of a secant line PQ, if you have another point and connect them, this blue line becomes a secant line, is average rate of change, m of PQ is delta y over delta x, or y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Simply put, rise over run. We could write it in this fashion if we go with f of x minus f of a over x minus a. If we go with this one and this distance is h, then f of x minus f of a over x minus a becomes f of a plus h minus f of a over a plus h minus a becomes h. And if you call this point b, then f of b minus f of a is b minus a, because b coordinates would be b f of b. Now, also notice as we connect P and Q, and then we get closer and closer and closer to P, it gives rise to the red line, which is the tangent line. The tangent line is the limiting position of the secant line PQ as Q approaches P. The tangent line is a line that touches a curve at a specific point without crossing it. Slope of a tangent line, also known as instantaneous rate of change, is defined as m of tangent line is the limit of m of PQ as Q approaches P. Or you look at this one, limit of f of x minus f of a over x minus a as x approaches a. This one as x approaches a. Or if we go with this one, the limit of f of a plus h minus f of a over h as h approaches 0. Now, that is also known as the derivative at a, f prime of a, or the slope of a tangent line at a. How do you find an equation of a line? Three ways. How do you write them? Three ways. Standard would be ax plus by equals c. Point slope y minus y1 equals m times x minus x of 1. And the slope intercept form y equals mx plus b. So if I use that to find an equation of a tangent line at this point, I would write y minus y1, which is f of a, equals m, which is f prime of a, times x minus x of 1, which is a. Now you can memorize that or just remember the point slope, and therefore you have the equation of a tangent line. Rates of change. And again, we are looking at the graph. The difference quotient, delta y over delta x. There are various formats of writing the difference quotient. We saw that. For example, if this point is x sub 2, we say f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1 is called the average rate of change of y with respect to x over the interval of x sub 1 to x sub 2, and can be interpreted as the slope of a secant line PQ. We recognize the following limit as being the derivative f prime at x sub 1. So instantaneous rate of change, limit of delta y over delta x as delta x approaches 0. Or limit of f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1 as x sub 2 approaches x sub 1. And these two, we have seen it from the previous page. The derivative f prime of a is the instantaneous rate of change of y. F of x with respect to x when x is a. And there are two ways to write them. And so average rate of change is the m of the blue line, the secant line. Instantaneous rate of change is the m of the red line, the tangent line, or f prime of a. That's the synopsis of what we need. And now we are going to find the average rate of change for the function f of x equals x squared minus 3x from 2 to 4. First, I want to look at elementary algebra. The average rate is simply rise over run, f of b minus f of a over b minus a, f of 4 minus f of 2 over 4 minus 2. So first I want to remind you of what we've already done, and it's very straightforward. Now plug in 4, plug in 2, the denominator, of course, 4 minus 2 is 2. If I put 4, I get 4 squared minus 3, 4. If I put 2, I get 2 squared minus 3 times 2. Now this is 16 minus 12 is 4. This is 4 minus 6 is negative 2. 4 minus minus 2 is positive 6 over 2 equals 3. This is fairly basic, everybody. Find the instantaneous rate of change of f of x at x equals 4. First of all, I want you to know, when they give you 2 points, even if they don't mean, they don't say average, that's what it means. If they give you 1 point, even if they don't say instantaneous, that's what it means. So we are going to find with one of those definitions. In fact, for practice, I'm going to use both in a moment. So first, one of them, limit of f of a plus h minus f of a over h as h approaches 0, where a, of course, is at x equals 4, a is 4. So we want f prime of a, meaning we want f prime of 4. Replace the a with 4. So you can evaluate this, simplify, and then at the end write lim as h approaches 0 and apply the lim. But at the end, you have to have that to apply the limit of h approaching 0. So having said that, what is f of 4 plus h? We go to the original function and we say 4 plus h squared minus 3 times 4 plus h. What is f of 4? We've already wrote it here. We can write it. And more importantly, this one, just use the fact that we came up with 4. This one was evaluated. And what about this one? Reminding you about a plus minus b quantity squared. That is an identity that you should know how to do it. So a squared plus minus 2ab plus b squared. So this is 4 squared, which is 16. 2 times 4 times h, 8h plus h squared. This one is minus 12 minus 3h minus 4. Number 16 with negative 12 and negative 4 cancel each other. So we are left with HA, 8h plus h squared minus 3h, and these two combine into 5h. We're going to factor the h out. We drop the common factor of h. So the limit of 5 plus h as h approaches 0. And this is what I mean, everybody. You can apply that. If you don't have the lim sign at this step, 5 plus h is 5 plus h, and you can't simplify it to 5. You can't replace the h with 0 if you don't have the lim sign, because it happens often. I'm mentioning it now. You want to be very careful with that. We're done with that, but I thought, why don't we look at this also? And of course, a is 4. So f prime of 4 is the limit as x approaches 4, f of x minus f of 4 over x minus 4. Just for practice. So what is f of x? X squared minus 3x. What is f of 4? We've already calculated to before. And I hope you see, if you plug in, you get 0 over 0. This can't be fixed unless you can factor the numerator, and it has a factor of x minus 4 to be dropped. So you can see it's easily factorable. You want two numbers. The product is -4. The sum is -3, which is -4 and 1. X minus 4 drops. You get limit of x plus 1 as x approaches 4. And now if you replace the x, you get the same answer as expected. Find an equation of a tangent line to the parabola y equals x squared at point 1, comma. First and foremost, in order to find an equation of any line, you need two things. You need a pair and you need a slope. The pair is given. I'm going to calculate this. But before we move on, they don't have to give you the pair as long as they give you x coordinate is good enough. For example, if they said x is 1, y is 1 squared root of 1. If they said x is 2, y equals 2 squared root of 4. If they said x is 5, y is 25. So you can figure it out. And now we want to use one of those formulas to find the slope. We notice a is 1, f of x is x squared, and we're going to start with one of them, but for practice, I'm going to look at the second one also. So let's start with this. The limit of f of x minus f of a over x minus a as x approaches a. This is m or f prime of a. Replace the a with 1. So m represents f prime of 1, the limit of f of x minus f of 1 over x minus 1 as x approaches. Sometimes 1 is easier than the other. So we replace f of x with x squared and f of 1 with 1. And if you plug in, you get 0 over 0. Needless to say, this is x squared minus 1 or 1 squared or 1 cubed, anything you needed. And reminding you that a squared minus b squared is a minus b, a plus b. So this is x minus 1, x plus 1. And so you have the limit of x plus 1 as x approaches 1. You replace the x with 1, you get 2. This is the slope. So we're going to use y minus y1 equals m times x minus x of 1. That means y minus 1 equals m, which is 2x minus 1. So I'm saying you don't have to memorize the formula for the equation of a tangent line, but just stick with the point slope. So having said that, this is 2x minus 2 plus 1, or 2y equals 2x minus 1, and this pair belongs to the function. Also, it should work with this one, and we're done. But for practice, I'm going to find the slope the second method, in other words, using this one, which is actually more popular. So I want the slope, f prime of 1. So I'm going to replace the a with 1. So what is f of 1 plus h? It's 1 plus h squared. What is f of 1 is 1, so we replace him. 1 plus h squared, a plus b squared is a squared plus 2ab plus b squared. So 1 squared is 1. 2 times 1 times h is 2h, and h squared. 1 and minus 1 cancel each other. At the top, I can factor the common factor of h. The 2 drop. And now, if I apply the 0, this is important. You have to have the lim sign at this point. You can't lose that. And now plug in, you get 2 plus 0 is 2, and that's exactly what we have here. This is how you do it with the second method.